So in the very beginning, we did a safety key, and everybody had kind of a glazed look on their eyes of what are you doing and why are you doing that? All right, so we're a little further along now with where you're at in the exercises and the assignments. So we're going to tackle the finger guide. And one of the things that I like about these isometric views is they're a little more complicated than what you're at in Chapter 1, Chapter 2. And this is more along the lines maybe chapter 3 or a little more detailed in Chapter 3. These are also a little more what's the word? They're similar to what you're going to find in the CSWA as far as what you're looking at is in the way of geometry. So if we were to look at the finger guide as a CSWA project, you would have maybe this isometric view of what it looks like. We would go over one screen. You would have a front view, you would have a side view, you would have a top view, and then whatever details are in that grouping. So a good portion of this is thinking in 3D. And again, what I like about the engineering design and graphics with SolidWorks is there's a lot of little projects that are repetitive in nature, and you're stepping through that process over and over again. Well, these are a little more complicated, and way back when in 2000, whenever it was that I had the time, I got out my technical drawing book from my first drafting class, and I sat down and I did all of the exercises, all of these figures in about 40 hours. Right, so from a speed standpoint, the things that you're going to encounter, the things that you have problems with, it's that repetition and going through the process that's going to kind of highlight those areas. The other thing that our text is weekend is the revolves. So we'll do a couple of, we'll do probably these two tonight. This one has the whole call out, and we'll look at the whole wizard with it. One of these classes, but I want to go over into the revolves as well, just mainly because it is such kind of a blind spot. There's maybe half a dozen objects that we can do with the revolves, and I think it's kind of a weakness of that particular text. So what I see when I look at this geometry is that we have the several prismatic shapes. We can do the little house shape, or we could go back and do the finger shape on the base and come up to this point, and then raise up from there with some chamfers. There's a couple of different ways to approach this. If we're comfortable with the contours and regions, doing what would be a 2D top view is a good strategy, because I can share this sketch, generate everything up to this level, share the sketch and generate everything up to this level, and it's one sketch that I have to deal with even though I'm generating two features. All right, so a couple different ways to look at this geometry. Oh, where did my SolidWorks go? There we go. All right, so this is going to be in inches. And we set up for an inch template, so we're going to see how that works. I still didn't correct my spelling. And the other thing is, it's not super critical that your models look exactly like the isometric views in the book. The test is your geometry valid? Is it stable? And regardless of orientation, position, when I put it into the assembly, is it representative of what's going to work? So on this one, I'm going to go into the top view and open up a sketch. And I've identified some symmetry from the kind of the top to the bottom, or left to right. So whenever you see symmetry, you're going to go directly into a center line. Horizontal in this case, I'll make it infinite length because I don't want to run out of center line. And then I just go back into to the select. All right, I'm going to trace this outside shape. And when I get over to the last portion of it, I don't really want to include the circle just yet, or the arc. This is the point where I can go ahead with the mirror. Right, so if I select left to right, the center line is not going to be included. If I select from right to left, center line is included. I can go directly into the mirror and get the continuation of the geometry. Now when I go into tangent arc, I have something to connect the other end to, and we'll have that finished shape. To make this like the 2D drawing then, we have a line somewhere in about there. As soon as I put that line in, now I'm into the contours and regions. I've made a decision that says there are two separate areas here. There's a complete contour, and then there's an intersecting region that we can go pick from. All right, so all of that sketching comes back to I should have inferred all of the relations, or at least the relations that I need. And now we're back to picking up the geometry. And not sure what I just put in, so let's double check it. 1.5. Might have put in 150. I have to go back and watch the video on that one. All right. Let's see. We have a 0.26. 0.94 to the edge. Let's go ahead and get the overall in place, and 4.12. And we'll go ahead and drag that one out a little ways. We have a full radius for 0.78. I'll go ahead with that dimension, and it's pushed back 1.12. And then a width of 0.46. So what else? What am I missing? Oh, the overall width then is 2.3. All right, so that's starting to come together, look pretty good. And then being careful or observing the angled line, keep in mind that we can go horizontal, and if I get close to it, I'll be in a linear dimension. When I come off to the side, then I'm in the vertical dimension. So I want to make sure to pull far enough down that I can get that linear dimension. So 1.9. All right, so with that shape, I have enough information to go ahead and extrude boss base. And because of, again, that one line, I'm into contours and regions, and the center line is going to split to where I have to select the inside regions. So the blue box on the lower left also has the contour. I want the entire shape through the first part, and it's going to be a distance of 0.76 tall. Okay, so that's item number 1. I want to share that sketch, reuse the geometry that I created. So expanding out next to the feature, going back to sketch 1, making sure that it's highlighted, I can go right back into the extruded boss base, and we're selecting for contours and regions. Those are the two areas, the two regions that I want to make a little bit larger, and this is going for a distance of 1.5. All right, so in this case, because the merge result is on, I have a positive into a positive, and there's no net gain in volume or mass. And if I turn that off and I have two solid bodies, then I have an overlap of mass, and would have to take that into consideration for any of my engineering calculations. All right, so we go ahead and accept. And that gives me the majority of the geometry. All right, now I can go into a sketch on the front face and sketch the chamfers, but we need to introduce the chamfer tool at some point. So underneath fillet, we have a chamfer feature. So fillet and chamfer are both under the fillet, And when I go into the chamfer feature, well, that was selected and that wasn't what I wanted. And we'll go pick the two faces. All right, so we have an angle and distance. Well, we weren't exactly given an angle and distance. So yeah, we're 30 degrees and 0.44 on our numbers. So 30 degrees and 0.44, and then we want to look at the preview. So that one looks close. We'll see what the preview looks like on that one. All right, so based on the preview, we had an arrow coming this way. We had have the arrow going down on this one, so I need to reverse it. And you can pick on the arrow and flip the direction, or we can come over to the checkbox and flip the direction to see what the result looks like. So that doesn't quite look long enough, and we don't have anything to really shift that that distance. So we're going to have to go to the adjacent angle, and that means that I can do 90 minus 30 degrees to end up with a 60-degree angle. Flip the direction, and then we'll check edge 2 and flip the direction, and that looks a little bit more like what I wanted to end up with. All right, so when you're working with the chamfers, keep in mind that what you're selecting, or what the direction of that that chamfer is going to be, something that you're going to have to manipulate and possibly pick a different angle or pick the adjacent angle to make it work. All right, so I'm going to go ahead and save this one. And this is figure 6, finger gap. Okay, so the shapes may look a little on the complicated side. The task is to break it down into manageable geometry. All right, so going into the tailstock clamp, then what jumps out is we have this nice profile out front, and we also have symmetry about the midline of the part. With the slots, we'll use the slot tool, and that part is in metric. So file new, part millimeter. Oh, that was one I made specifically for illustration. I have to pull that one back out. So in this case, I want to be on the front plane, and with symmetry, we're going into the center line. This time it will be vertical, infinite length, drop it on the origin. Go back into the line command. We're going to come up to this point, and with the continuous tangent arc, I can start the line, go back to the start point, and the direction that I drag will give me the tangent arc. Now, what I'm not sure of is that this radius is probably going to be below this line. So if there's an inferred relation there, I shouldn't have got out of the line. We need one more. There we go. And then I'll check. We got a tangent there. And in the process, we ended up with a coincident relation back to this line. That was not something that I needed. So highlighting those little blue boxes or little green boxes, I can delete. And then we'll be able to drag to a new location. So I want my overall. Again, if I go left to right, the center line is not included. Right to left, the center line will be included. If we go without, then mirror about. We'll select in the mirror about. Once I see this property manager, that'll show me a preview, and I can accept. Okay, now my distances go in for each of the sizes. So 105, 127. That was interesting. 38 on the height. So we'll see what kind of weird things we can get this to do. 9 on the height, the edge, and radius of 29 on the sides. All right, so if I'd left this center point even with the line, then we would have ended up being, well, it does come out normal distance of 0. Let's see, does that add up? 30, 29, and 9? Yeah, it does add up. So can't really make the assumption, but in that case, it did work out where the coincident would have held it. For this one, I want to be midplane. So I'm going to extrude, go to the midplane, and the width is 58. Alright, so we're ready for the slot geometry. Alright, so we've generated this outside profile, we've made the width, and the reason that I went midplane was the slots are conveniently enough down through the center of the part, and the notch. So on the notch, we'll go into the right plane, open up the sketch. I'm going to draw a rectangle in relation to the part, and then right-clicking and selecting the midpoint, we can go up to the top edge and make that a midpoint, and that will establish symmetry without actually having to put in centerline or any additional relations. When you get the little blue arrow, all right, so the four-headed blue arrow means that I selected an endpoint and a line, and it's asking me for an extension if this were an angle. All right, so in this case, when you see that, we're going to hit escape. What I would expect to see, let's just kind of draw a line out here. So as an example, if I grab the endpoint and the line, it shows me the arrow. It's asking me where I want the angle to be placed, and it will give me that internal or adjacent angle for the angle. All right, so we're not ready to do that, but since it popped up, we'll take a look. Our dimension then is 11 on the step, and is we're missing, so 11 on the sides, and because of the symmetry, that should be the only one I need. All right, so when you're sketching internal to the part, so this is inside of the base feature, we'll go ahead and extrude the cut, and through all in one direction we'll find the terminating edge or the terminating feature. Through all both we'll find turn on direction 2 and make it through all in both directions. So I don't just want half of the cut, I want to make sure that it takes all of the cut. The other options would have been to draw the rectangle on the top plane and extrude it down 11 millimeters, or on the front plane and extrude it back and forth, offset from 11 millimeters. All right, so that generates the notch geometry. All right, going back into the sketch and the bottom of the notch, we have 2 slots, and we'll go with kind of the old style and the new style. So new style is a straight slot, and looking for the inference, draw the center line, and as we drag out, that gives me my slot feature, or my slot sketch. It is a radius of 4 times, I think it says 13. All right, so we'll go with 13. And the length is 19. I'll fly that back in. All right, so 19, 14, since I didn't pick the bottom face to sketch on, then I have to have some means to put this 14 millimeters in relation to that bottom edge. And to do that, we can either rotate over to where I can see it, and because this edge can be projected into the current sketch, it is valid geometry to select from. So my extension line gets projected into the current sketch and shows up as a reference, or it shows up as a dimension. Okay, so the old style, the way we used to do slots was draw the line, do the continuous arc, go back into line, go back into the continuous arc. Okay, so I'd expect to have, well, got tangency on both ends, got tangency on both ends. My vertical, I need to place horizontal to the origin. Set the width for 13, so it picked up something there. And then the other method would be, instead of rotating over, we'll go to the hidden lines visible, pick the hidden line, pick my arc, and give it the 14 dimension, and go 19 on the width. All right, so if I build it myself, I get this. If I use the slot tool, I get this. And both of them are pretty much the same, going to be the same geometry. Go ahead and make the extruded boss base. Oh, went the wrong way. And let's go ahead and accept whatever that is. All right, so item of note is Instant 3D will allow me to switch between a boss to a cut. So I can grab onto the arrow, and as soon as I drag back through the geometry, then it becomes a cut. Now there's nothing really there to select. If I left this as a blind slot, I could drag the base back up, and I guess as long as the arrow is accessible, I can drag it and reverse it. And then that changes to the cut extrude 2. And when I edit its feature, then I can go up to next or through all. And then the last two pieces of geometry. Now notice when Instant 3D is on, I'm getting the XY. I'm getting those handles, which is asking me if I want to drag. So I'm going to go ahead and turn those off. We'll go into the fillet. And the fillet rounds are 3 millimeters. Okay. So we'll go ahead and save that one. And go to the tailstock clamp. All right. So one more with Symmetry. We have the rod support, and Symmetry is again kind of through the middle. And I want to show the dynamic mirroring. It's not one of my favorite techniques, but it is useful to know how it works. This is a metric part. So on the front plane, we're opening up the sketch. I'll go ahead and put in the center line for reference, infinite length, vertical, and place. And let's see, under Tools, Sketch Tools. There it went, Sketch Tools. We have this thing called Dynamic Mirror. And Dynamic Mirror will draw everything that I draw on one side, it will also draw on the other side. So select a sketch line or linear model edge to mirror about. There's my center line. And so I draw a line, I get the opposite. And I went too far. Okay. Now that dynamic mirror will stay on until I go back and turn it off. So it'd be one of those things from a customized standpoint. If you're going to use it, add it to the to your command manager somewhere. Otherwise, tools, sketch tools, the icon is still highlighted. You need to unhighlight it, deselect it, and we're ready to start adding dimensions. So overall is 113. And height of 13. Let's see if we can get this to flip-flop a little bit. Height of 64. Didn't do too bad. I guess the main thing with the sketching is, as things invert and do strange things, is that you be able to identify the geometry and put it back in sorts. Alright, so the width is 19. And spacing is 25. And then the height, 13. And height of 17. Alright, and the base width of 35. So no great advantage to going mid-plane, blind, one way or the other on the extrusion. So we have a width of 32. And that'll build the shape. Alright, so circle. And I want this to be centered, so my design intent says I can either put in a center line and relate the center point to it, but I can also right click and go back to select midpoint, control select the center of the circle, and make that vertical. Height dimension is 46, so grab that for me. And what do we have? 13 millimeters for the clearance. So this is a good illustration of what happens when, get to the isometric view, what happens when we go up to next. So through all finds the very last piece of geometry, the back face. There's not really a through all both, but if there were, it would find this face. And if I go up to next, it finds the end geometry. Let's go ahead and turn direction 2 off again. Alright, and in reference to the arrows, I have a single arrow that is direction 1, double arrows that are direction 2. Up to vertex, if I pick any of the intersecting corners, I'm going to get the different results. Up to surface, picking a surface. And let's see, do we have anything else? Offset from surface up to body midplane. No, those don't really fit, but it does illustrate what the other end conditions can do. All right, so the two on the bottom, as long as these legs end up at the same height, I can open up a sketch on this face, and it will carry over through that plane to the other face. So circle of 13 millimeters. Nope, 11 millimeters. Distance of 13. And 13 off of the outside edge. All right, so I want a mirror, and I need a center line to perform the mirror, so if I don't recognize it immediately and put it in, I can always put it in later. Select, go into the mirror entities. It'll grab the center line and the circle in this case, and that puts me to where I'm ready to create the extruded cut. And then it will be through all or up to next. So chamfers and radiuses usually go in last. So we'll wait on the radius. The arc then, radius of 35 on this arc comes up tangent, and we have a couple of locations. Well, I can't do tangent. Sort of know where the center point is, but not really. Could calculate it. 64 minus 35. But I'm going to want that arc to be tangent to the top and coincident to the endpoints. So I'm going to go Control 8, Normal 2. We're opening up a sketch, and this is a good place to use the 3-point arc. A 3-point arc says I can start, end, and that's about what it looks like. When I go in to set the relations, then I can set tangency. We can go ahead and set for a horizontal, and when I apply the dimension of 35, that should take it to be fully defined. So in certain versions, we'll see if it does it here, the point where this circle, the single point where this arc or circle touches that edge is a 0 thickness. And if it's going to fail because of 0 thickness geometry. So when we extrude cut, the direction of cut and the area, we're going to go through all. And because this is an open profile, it's not closed off, by default it will go through all. 2016 they added a blind condition for the cut extrude, but I don't really think they should have made it default. They should have made it the default. They should have left it at through all. But it may just be the first thing in the list too. So we'll go ahead and accept, and it makes the cut. So if I were to get a 0 thickness error, I would go back into the sketch and draw a little extension onto the sketch, make it to where it would make a cut complete through the part. So getting into the other chamfer, on the right mouse button or on the pop-up, we can go directly into our chamfer. It's going to be 45 degrees. We have the last one, the previous settings, and I have a distance of 10 millimeters. So 45 is equal. I'm not worried about the direction. You go ahead and accept, and that makes our rod support. And that is 657. Okay.